Hey guys, welcome back. I got ahead of myself and forgot to film anything, so let me get you caught up. So, last time we had everything on the board, I said, we forgot these two jumper wires. So these little black wires, I forgot to put those, got those on there. It's just, for now, it's a pair of 14 gauge wires. May go with something beefier, but we're going to see how these do. But they look actually really nice. I thought it would look like crap. Turned out good though. So those are soldered top and bottom. And that just basically that battery post ground, it gives you a better ground signal to that other MOSFET. Because the one on the left is really close and it's got a really good top and bottom that's uninterrupted. Whereas on the top, on the other one, you see the top where these little resistors are, the circuit's interrupted right there. So I just put three 0 ohm resistors to jump over that trace. And then it continues across that narrow piece until it gets over here. And on the bottom, it's not interrupted, but it still follows that narrow dimension, whereas over here you got this big wide area. So I beefed it up with a couple of wires. That should help. So we got that on there, and then my goal was I wanted to do a soft power up. So basically that is you do some type of current limiting and you kind of power it up slowly and make sure everything's okay, nothing's getting hot, you don't have a short circuit, anything like that. So you can see down here there are a 5 amp fuse in it. We're not expecting that this is a 1 amp supply we're hooked to. Oh yeah, here's our supply. So this is just a BK Precision, 30 volts, 1 amp. Pretty simple. So I basically just set the current really low and I set the voltage at 15. And we did a power up and it wouldn't turn on. That's because I forgot to hook this wire up. So that's your ignition switch wire. So this thing doesn't turn on until the ignition switch turns on. So I just ran the wire I put the plug in, hooked one wire up, and just jumpered it straight to the 12-volt terminal. So once we did that, it did turn on. Let's see. Yeah, so that came on, and I had some problems communicating with it. Yeah, I couldn't program this, which is weird. And after looking into it, I accidentally used one of my input pins that's used for programming. So you can see this trace right in the middle here is scratched out. I basically cut the copper on that trace. See if we can zoom in on that. Yeah, there we go. Sorry for the bad focus. Basically, that trace, I just cut it with a knife. So there's no connection there anymore. That connection was dragging down, or dragging up, the reset pin on the Arduino, which I carelessly forgot about. So I don't need that pin right now. That's a ground to disable feature, which we can have later. There actually is one spare pin on this that I'm not using, so I'll just use that on the next version. So fix that, then it powers up. Put a little code on it. So eventually this is going to be running a 50 amp load. As we can see, I just got an LED hooked up, and this is 13 milliamps. So we got about 3,800 times higher current for the design limit versus LED. However, I just wanted to see if it works at all, and it did. So at first I just put some blink code on it and made the LED blink, and it worked. And we checked the signals through all the MOSFETs, through the CPU, through the gate drive on the right. That's the one with all the features. And then we checked the gate drive over here. And I actually didn't check the other one, but I assume it works because it's the same design. Probably should check that. And it was switching the MOSFET on and off. So then I fired up my scope over here. We hooked up the signals. And I was actually showing a 10 millisecond edge. However, there's hardly any load on it, so I'm hesitant to believe if it's actually going to do that under real world loading. But anyway, it did look good, and it was switching on and off. It looked clean. Then we did some PWM code. So I'll show you that real quick. So here's our LED. This isn't really exciting, but basically you turn it on, comes wide open for a couple seconds, off, and then you see it kind of starts off dim. And this is just a PWM ramps up from 0 to 100% duty cycle. So that'd kind of be a boring video, but you can imagine over time that light gets brighter. So it works. PWM's functioning. Looking good. So it's really late, so I'm going to stop working on this for now. But the plan is tomorrow we disconnect this little baby supply that's 1 amp. And we come over to this guy, which is 50 amps. And we'll start off running probably Really don't know. We'll pick something with a low amount of current that's inductive load. We'll turn it on and off, check our temperatures, and then we'll start ramping up and hopefully get to 50 amps. I do have one other thing. This is kind of cool. So I bought this little guy. So this is a 4-channel thermocouple. So let me turn it on real quick. Yeah, so you can see a little screen. We got 4 channels. They're all showing pretty close, 75, 76. So I got 4 little thermocouples. And at some point during testing, what we want to do is we're going to probably somehow attach the thermocouples to different parts of the board. So probably one on each MOSFET, maybe one on a diode, maybe anything else on it that's getting hot, like a gate drive or power supply. But the goal is I want to actually measure the temperatures, maybe on the board, on the components. But I got 4 channels, so now I can do some, we can do relative measurements at the same time and test it under different currents and see how it performs. So that'll be really good data to have to kind of, put numbers to the performance. That way I can make changes on the next revision to improve things and then see what the effect is. So yeah, that's it for now, but tomorrow we'll do some high current testing and see how this performs.